The hyperbola is the set of points in a plane whose distances from two fixed points, called its foci, which is the plural of focus, has a difference that is constant. A hyperbola also has two vertices. That's the plural form of vertex. And for each hyperbola, we identify what's called the transverse axis. The transverse axis is parallel to or the same as the axis as the variable that is positive in the equation. Each hyperbola will have two asymptotes. So we have two vertices, two foci, two asymptotes, and transverse axis. The transverse axis is a line through both vertices of the hyperbola. So just to give you a little quick sketch, let's say that the vertices of my hyperbola are here and here. The hyperbola will look something like this, okay? And in this case, the x-axis, which is y equals 0, is the transverse axis. Okay? So we'll be able to tell that because the x squared variable will be positive in the equation. Okay, so it's the x-axis if the x squared variable is positive. Now this is just for those that are centered at 0, 0. Later on, this transverse axis can be moved up or down. Okay, now the other version for a transverse axis is when the y squared is positive. And you'll see the format of the equation in just a minute. But by identifying what a transverse axis looks like, when y squared is positive, your vertices will be on the y-axis, and your hyperbola will look something like this. Okay, y squared is positive, so this y-axis is the transverse axis. Now, remember, it's a vertical line, though, so its equation is x equals 0. Okay, so let's look at the parts of the graph of a hyperbola with a horizontal transverse axis. So we'll put in a few more parts. When you have a hyperbola, it'll have two vertices, okay? It'll also have two guide points. So I'm going to put a point here and a point here. Now I'm going to label this as vertex 1 and vertex 2, and these are just guide points. And what we do with that is we draw a rectangle through these 4 guide points, and then we draw in what we call the asymptotes, and those connect the corners. Okay, now the vertex is there on the axis, and the foci will be on the same axis, and they'll be somewhere inside of the graph. So we'll call that foci 1 and foci 2. And the equation will look like this when graphed. So it'll come right next to the asymptote and hit that vertex, and then go right next to the asymptote. And then it'll repeat over here. It'll go right by that asymptote through the vertex and right by that asymptote through the vertex. So the black lines are really the only graph of the hyperbola. Everything else is for guidance of how to draw it. Now, if you have a vertical transverse axis, that means that your vertices are going to be on this axis. Okay? So that's vertex 1 and vertex 2, and your guide points are going to be on this axis, so we'll put them here and here. Okay? And then I'll draw in my rectangle. This helps me get my asymptotes. So my asymptotes go to the corners of this box, All right, I got to try to get those right. And then I know that the hyperbola has to go through the vertex, and look, if it's got a vertical transverse axis that goes through both of those vertices, then we draw this line, this curve, close to the asymptotes and through the vertex. So close to the asymptotes and through the vertex. Okay, and those blue dotted lines there are just for guidelines. So the parts are, of course, the graph, okay? Number one, the graph, that's these two black lines right here. Okay. The vertices, so we've got a vertex here and a vertex here. We've got two guide points here and here. And I haven't drawn them in yet, but let's draw in the foci. Will be about here and here, and I'll show you how to find those exactly. So foci 1, foci 2 will be on the transverse axis. So here's your transverse axis. And of course, you also have these blue dotted lines that I've drawn here, and those are the asymptotes. So those are all the parts that we're talking about. And it's, once you draw a couple of these, drawing in the box and getting your vertex, your two vertices on the transverse axis, it's really easy because you just draw the curve close to the asymptote through the vertex. So close to the asymptote through the vertex. But you got to be sure and identify what's your transverse axis so you know where to put your vertices, because you've got these guide points too. Okay, so here is what the equation of a hyperbola is going to look like. If the horizontal axis is the transverse axis, okay, that means the x-axis is the transverse axis. It's going to be x squared over a squared minus y squared over b squared equals 1. Now that's similar to the ellipse. Remember, ellipse is x squared over a squared plus y squared over b squared equals 1. So the only difference is there's going to be a minus in your hyperbola. If the transverse axis is vertical, it's going to be y squared over a squared minus x squared over b squared equals 1. Now both of these have centers at 0, 0, 0, 0. And the way I identified the transverse axis is like the x-axis is the x is positive, okay? If the transverse axis is vertical like the y-axis, the y square is positive. So this first variable tells you where your vertices are, basically. That's just what you remember. Whatever variable is first, that's where you're going to locate your vertices. And I say first, that's if it's in this format. If you have to move things around, it's whichever one is positive. So here the vertices are going to be on y. And here they're going to be on x. So to identify the transverse axis, you look for the variable that is positive in the equation. The transverse axis will be parallel to the axis of this variable, that should say of this variable. So the transverse axis will be parallel to the axis of the positive, in other words, of the positive variable. And all you need that for is to tell you that it's going to go through the vertices. It's going to tell you which of the points are your vertices. So let's look at the steps for graphing. You kind of saw it when I sketched that other one, but the first thing you're going to do is you're going to find positive and negative A and positive and negative B. And those are going to be the points that you plot. Of course, in this case, A is under the x squared, so we'll put those on the x-axis, and B is under the y squared, because A is always the positive one, okay? It's going to always be in that first denominator. Then we'll put the B on the y-axis here. Plot the points on the appropriate axis, identify the transverse axis so we know that those are the vertices, construct the rectangle through those 4 points and sketch your asymptotes, and then use the vertices and the asymptotes to sketch in the graph of the parabola. So let's do that first one. X squared over 9 minus y squared over 16 equals 1. Now remember, our format is x squared over a squared minus y squared over b squared equals 1. So we have to find our a and our b, and that's going to be the square root of those numbers. So a squared is 9, so a is plus and minus 3. B squared is 16, so b is plus and minus 4. So since the x squared is the positive one, I go to 3 and negative 3, and I label that as the vertex 1 and 2. And then my guide points are going to be on the y-axis at 4 and negative 4. So here's 4, and here's negative 4. So those are just guide points to help me sketch my rectangle. Now my transverse axis is going to be this one through the vertex like that. So that's my transverse axis. And that's because the x is the positive variable. And that's going to tell me that I have to connect to those two vertices and the asymptote. So I'm going to draw in my box, draw in my rectangle. All right, so you just connect those points with a rectangle. And then I'm going to draw in my asymptotes. They have to go through the corners of the box. And later on, I'll show you how to write the equations of those asymptotes. Okay, and remember our center is still at 0, 0. We haven't moved it yet. But since I know where the vertices are, I connect the vertices and I approach the asymptote. So make sure you go through the vertices and approach the asymptote. Through the vertices and approach the asymptotes. And so that's how you draw a parabola with a horizontal transverse axis. Okay, that's the first kind. Get your A and your B, sketch your rectangle, label your vertices on the axis that is has the positive variable, draw in your asymptotes, draw in your rectangle, and then sketch in the hyperbola. All right, so let's look at one that has a vertical transverse axis. That's the y-axis, right? Vertical is like the y-axis. Notice that the y variable is positive, and these steps are exactly the same, okay? Only the vertices are going to be on the transverse axis, and it's going to be vertical like the y, okay? So, what was it? It was y squared over 9 minus x squared over 16 equals 1. Now notice our transverse axis is going to be the y-axis. And all that does is it tells us where to put the vertices, and then it'll also show us the basic shape of our hyperbola. So look, a squared is 9. A squared is always that first one. So a is plus and minus 3. And b squared is 16. So b is plus and minus 4. So on the y-axis, now be careful, this is the y-axis, I go plus and minus 3. So 1, 2, 3. 1, 2, 3. Since that's the positive variable, these are my two vertices, vertex 1 and vertex 2. Now these other 2 points are just my guide points, but I'll go ahead and put them there, okay? And they're just there to help me draw in this rectangle. So I'm going to draw in the rectangle like that, and that helps me draw in my asymptotes. Got to go through the center and through the corners, right? So you just do the best you can like that. I didn't quite hit the center on that one, but you get the idea. Now, because the transverse axis is the y-axis this time, the graph is going to go through the vertex 1 and approach the asymptotes. So through the vertex 2 and approach the asymptotes. Okay, so if the y-square is positive, your transverse axis is the y-axis as long as your center, remember, is at 0, 0. We can shift it left or right later when we shift the center to a different point. But right now we're just looking at ones that are at the origin, centered at the origin. So my center's right here still, center of that box. And since the y is positive, the transverse axis looks like the y-axis. The vertices are on the y-axis. So your graph is going to intersect the y-axis in two different places at those vertices. Now the last thing we have to do is identify the foci. And there'll be points. Just a quick sketch right here. Here's your vertex and your vertex. Here's your foci are going to be inside like this. So foci 1, foci 2. So the foci, you find it the same way. Okay? To find your foci, that's going to be the variable c, and c squared is a squared plus b squared, like the Pythagorean theorem. So c is going to be the plus and minus square root of a squared plus b squared. So for the one that had the horizontal transverse axis, so that one was this one, right? Horizontal transverse axis, x squared over 9 minus y squared over 16. So x squared over 9 minus y squared over 16 equals 1. So c is going to be the plus and minus square root, look, of a squared, 9, and b squared, 16. And you add those, okay, even though that y is minus, you're going to add a squared and b squared. So that's the plus and minus square root of 25. So your c's are at plus and minus 5. So when I go back here, I go over to, that's 3, 4, 5. That's foci number 2. And over here, negative 5, that's foci number 1. So the foci are located at negative 5, 0, and 5, 0. So it's C0 and negative C0 when you have this horizontal transverse axis. It's like the x-axis, so the foci are going to be in the x location. When you get over to this one with the vertical transverse axis, it's going to be at 0, c, and at 0, negative c. And in both cases, c squared is a squared plus b squared, or c is the plus or minus square root of a squared plus b squared. All right. 0, c, and at 0, negative c, where c is the plus or minus square root of a squared plus b squared. And this is when you have this one is when you have this should be vertical. Yeah, this should be a vertical transverse axis. Okay, so they're going to be vertical is like the y-axis, so your foci are going to be on your y. All right, let's just draw a couple more of these where we have a center at 0, 0, and then there'll be another video where the center is not at 0, 0. All right, so let's say we have x squared over 25 minus y squared over 4 equals 1. So we're in the right format. So A is going to be plus and minus 5. B is going to be plus and minus 2. And your vertices are going to be on the x-axis because the x is positive. So I go 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left, and I'll go ahead and mark those as vertex 1, vertex 2, and of course our center is still at 0, 0, so I'll call it C. Now we put in our 2 guide points are going to be at 2 and minus 2, so here and here. And then I sketch in my rectangle. And then I sketch in my asymptotes. And since I know where my vertices are, I can go ahead and draw my graph. It goes like this, through the vertex, approaching the dotted line. So this, through the vertex, approaching our asymptotes. And so that would be the graph of that parabola. Now the foci are going to be at the square root, both plus and minus, of a squared plus b squared. So I've got 25 plus 4, so c is going to be the plus or minus square root of 29. Now that's somewhere between 5 and 6, so it's just somewhere about in here at the square root of 29. Foci 1, foci 2. And it's going to be square root of 29, 0, and the negative square root of 29, 0, because they're going to be on the x-axis. Let's do one where we have a vertical transverse axis. So that means y squared is going to be positive. So I would have something like y squared over 9 minus x squared over 4 equals 1. So A is plus or minus 3, and B is plus or minus 2, 3 and negative 3. And then I go to 2 and negative 2 on the x. You got to be careful with that. Then we're going to draw in our our rectangle, so we can draw in our asymptotes. Now my vertices are going to be on the y-axis because that's my positive variable, that's my transverse axis, so that's a vertex at 3 and at negative 3. And so then I can draw in my hyperbola by going through that vertex. And so that's the graph of my hyperbola. Now, the transverse axis is the y-axis. Its equation is x equals 0. So if you're asked for the equation of the transverse axis, it would be x equals 0 because it's a vertical line. My foci would be my c values, right? So it's going to be the plus and minus square root of 13 because 9 plus 4 is 13. That's a squared plus b squared. So the square root of 13 is somewhere between 3 and 4, so it's going to be somewhere in here, somewhere in there. I'm not too worried about you getting that exact location, but just know that the foci are there, and then you can write the foci as 0 square root of 13. That's this one up here. And then the other one is at 0 negative square root of 13. Now the last thing is the equation of the asymptotes. Okay, and these are pretty easy also. So if x squared is positive, then there are two of them, y equals b over a times x, and y equals negative b over a times x. And if y squared is positive, it's y equals a over b times x, and y equals negative a over b times x. So let me show you those just from this graph perspective. Okay, so here we said if the transverse axis is horizontal, it would be y equals b over ax, and y equals negative b over ax. Well, the slope is negative b over a or b over a. So it's going to be 2/5. Y is 2/5 x okay? And y is negative 2/5 x. So look, from my origin, I would rise 2 and then go to the right 5. And that would give me that point right there. So that's my first asymptote. Or from here, I could go down 2, 1, 2, and to the right 5, and that would give me this second asymptotes equation. So these are your asymptotes. Okay? And when x squared is positive, it's b over a times x, and negative b over a times x. Now, if y squared is positive, it's y equals a over b times x, and y equals negative a over b times x. So look, we've got 3 over 2, so y equals 3 over 2 times x. So look, if I start at the center and go up 3 and to the right 2, look, I'm in the corner of that box. And so that's that first equation right there, that first asymptote. And then y equals negative 3 over 2 times x. Start at the origin, go down 3 to the right 2, and that gives me the equation of this second asymptote. So 3 over 2x and negative 3 over 2x. And it's a over b and the opposite of a over b.